All right, what is up, everyone? Welcome to week 75 of Chill Kernel Hacking for Fun. Week 75, that is wild that we have been doing this for 75 weeks in a row. As usual, I'm just gonna kick it off with a test 0 in the chat. What's up, Offnon? Thank you for the test 1. You're right on time today. Yeah, man, 75 weeks of this. This is super cool. Yeah. Yeah. I was just making a bit of a quick recap of the history of the stream, actually, which I thought might be useful for new people that are joining the stream. Maybe I'll go into that in a little bit. But more importantly, I'm wondering why the chat widget isn't working today, which is always a bit tricky. Maybe it's a bit late. Sometimes it's a bit late. I'm just gonna do like a test 2. Did I mess up a config somewhere? I hope I didn't. Okay, we go. Okay, but this thing now, the box is just kind of too far over there. Just recenter that a little bit. Hopefully that's a little bit better. Okay, what's up, everyone? Hope you're having a great day. I'm having a nice one. Excited to get back and do some kernel development. Yeah, the plan for today in general is to stick with the C++ topic that we've been working with for a little bit of time now. I'm not exactly sure where I want to go with that, though. Really, my goal with the C++ thing is I just want to know what compiler flags you need to use C++ in the kernel, and just loosely have it all set up for doing C++ development. I don't necessarily want to port the entire OS to C++ like in this session necessarily. I'm more just interested in understanding the basics that are required to get C++ going. What's up, Gatout? We're not really focused on any particular subsystem today. We're focused on just kind of like the whole kernel with this C++ stuff. Yeah. Although, I mean, there's different ways we could go with it. But yeah. So I don't know. I think we'll just kind of get back in and pick up where I left off last week. And we'll see how that goes in terms of how difficult it is. And if it starts getting not fun, maybe I'll switch to something else. Yeah. Quick recap for people that haven't been around for the whole stream. I started streaming in early 2024 last year, and I was working on XV6 back then. I was just trying to find basic improvements I could make. So I worked on the build system a little bit, but that wasn't really fun, actually. So I switched over to JOS starting in early 2024, about actually a couple months after I started here. And then from there, for the past like year or so, I was working on JOS and doing that MIT course. And then now, as of the last couple months, we're just kind of doing whatever I want. And we were working on a bunch of boot stuff. And C++ support is sort of like the most recent hot topic. And then I have some other ideas for things I want to look into, like porting to 64 bits, and then also learning about segmentation, which is sort of a interesting and kind of esoteric topic on x86. Also, what's up, Soham? I didn't even know there was C++ in the kernel. Are we talking about the Linux kernel? No, we're not talking about the Linux kernel. We're talking about this random kernel that I work on in my free time, which is based off of this thing called JOS, which comes from MIT. And so, yeah, no, Linux is not really involved here at all, actually. Yeah, looking at that, a bit unfortunate that this chat widget is kind of clipped off. I wonder if I can fix that somehow. Let me just try really quickly. Okay, in theory, that should maybe help. Okay, bear with me while I just adjust a couple of things with that. Right. So you'll be doing paging and segmentation stuff too, all the memory management. Yeah, I'm not sure about if we'll get to that today. But in general, it's sort of on my kind of like topic list to look a little bit more into that, just because I'm kind of curious. Yeah, no, there's no C++ in the Linux kernel. Yeah, they are extremely against that for some reasons. Okay, so with all that being said, I guess let's get started. Okay, back here. So last time I was in the middle of things not compiling. Yeah, so we just sort of changed the build system to have some of these new CXX flags. And then we already started porting some of the code to make it compile. And this commit is just kind of me continuing with this. And then what file is failing to compile now? It is env.c. I mean, this might be an interesting experiment to try using AI. So, basically you will be going through the TSS descriptors and selector, all that too soon. Yeah, maybe. Actually, yeah, if we're like looking into segmentation and hardware, well, like segmentation and hardware context switching, yeah, we'll be using the TSS quite a bit. Yeah. What's up, Digitalized? Nice to see you. What's my goal? Yeah, I don't know. I don't have super specific goals. I have a general intention to build my own operating system once I have enough knowledge. But I think mostly my goal is just to explore the different technical topics I'm curious about for the moment. Yeah. Okay, so let's just get started and take a look at some of these errors. These are what we saw last time. And yeah, we'll just see what this involves. So let's start with the first one, env.c, line 45. So it's kind of unfortunate that this pattern is so common in the kernel, in the C version, and it doesn't work in C++. The pattern is we are allocating an array and we are partially initializing certain members or certain offsets into the array. At compile time, and yeah, and that does not, either all initializer clauses should be designated or none of them should be. What does that mean, actually? I think the problem is that this one is not a designated initializer. But it's pointing at this 3 thing. So just out of curiosity, I wonder what would happen if I did this. Wow, okay. Cannot type today. Huh. That's like kind of interesting because that actually fixed it. I wasn't really expecting that. Because we had a lot of problems with this kind of thing not working in like last week. So I'm a little bit surprised to see this pattern working and not causing an error in C++, where we are like initializing certain offsets into this array based off of like some kind of computation here. But whatever, let's keep it moving. It's 220. Okay, this is one of these casting issues again. So obviously I could just add a cast. Is that really what I need to do everywhere now? So everywhere this function is called, I need to cast it. Which is not super fun work. Okay, now I mean, you know what? One other thing we could do, I don't really love it. We could turn off W error. Because we are just running into so many problems with warnings that are being converted to errors. And yeah, maybe it would just be a bit faster to just let them be errors for the moment. Yeah, and just focus on the real problems. So let's, for example, 601. Oops. In values of void. Okay, so we're subtracting two void pointers, which is not allowed. So I'll just cast these both to char star. Yeah, okay, 607. I'm just trying to like move a little bit faster and see if we can get anything at all compiling. So Pritam, we are trying to compile the kernel with C++, with a C++ compiler, and just see what that is like. Okay, this is the annoying thing. where if you have go-tos, that becomes a problem with C++ because you're not allowed to initialize a variable in between a go-to and the label it jumps to. So for example, we have 3 variables, and let's just ask AI to solve this problem. I'm just going to copy in this error. Paste. I have an error. Can you move these variable declarations to the top? Oh wait, shit, I did it in ask mode. Okay, but maybe it still can do stuff. Wait, let me just stop this. Put this in agent mode. You move these variable declarations to the top. Word. Okay. So basically all it did is, okay, moved, actually, I think we didn't necessarily need to move this one to the top. But it moved these other ones there. Actually don't need to move struct elf to the top. Yeah. Yeah, I've been using Copilot a bit more recently, and I'm trying to understand how to use it better. Okay. That's cool. So, what does the compiler say? Compiler says we have some warnings, but whatever. We are ignoring those for now. Maybe I can just ask it. So one thing I just want to quickly do a check-in on is like how much longer is this going to take? This is like not super interesting debugging work or like just making it compile. But I think the good news is it's now failing on trap.c, and assuming it's kind of just going in order, we can even maybe just check. I mean, you can see pick, print, okay. Pick, printf, blah, blah. So I think it is going in order. And so relatively, like speaking, it won't be that much longer before we get to the end, I'm hoping. So let's just keep going, and let's see if we can use AI to help us. So I'm just gonna add the current file to the add file to chat. All right, I mean, like I could also just literally copy in all of the errors. Yeah. Okay. Can you fix these, please? So the errors are, it's just another boring error about the goto, basically, and then one warning. Yeah, what's up, Bacon? Long time no see. Nice to see you. All right, so it gave us a fix for the goto issue. Nice. And it is claiming, is there another? Let's just see what happened. Yeah, that worked. Okay, that's cool. I'm just gonna do the same thing, and we'll see if we can just speed run getting it to work. Syscall.c. Kern syscall.c. Can you fix these two? What's up, AA? For the C++ transition, is this some older long-term thing you're patching up? Yes. Yeah, well, also welcome if you're new. Yeah, so this kernel that we're working with right now it's called JOS, J-O-S. It's from MIT, from this OS course, and I've been using it for over a year, just following the coursework and kind of playing with it as my own kind of test bed for experiments. And this is the latest experiment which I'm running with it, which is seeing what it's like to use C++ with it. Yo, Lizard, what's up? We got packed. We got all the people in the house today. That's cool. Hope you're doing well, Lizard. We're heavily, yeah, let's see. Okay, so I'm just trying to use AI to speed through all these boring issues which are not very interesting. And let's just see. Okay, another one of these go-to things. Invalid cast. Where? Okay. So some kind of casting problem. And C compatibility. Dang, already time for a 20 second break. Be right back. So actually, I don't know if it fixed that correctly. What was the problem? What is this? Env is a pointer. I'm actually gonna, how do I reject this change actually? It's giving me a diff view. All right, I'm going to, yeah, I do not actually like that change. I don't really know why it did it. Well, first of all, I don't really see an error message about this. Yeah. Okay, I'm going to reject that one. But I'm going to accept these two. Accept, keep. All right. Okay, now, what are the errors? Redeclaration. Is this what it was talking about? No. 281. Okay, so, okay, wait a sec. Wait. And syscall, let's see. So because I did, yeah, because I rejected that if it didn't really work. Okay, but now what's up with here? So, same thing. Okay, we need, yeah. So that squiggly warning line is just because the file type is, it still thinks it's C because we never changed the file extension. What's up, my Fu Manchu? Welcome to the Twitch chat. You're leaving when I just joined. Good news is that I just started 30 minutes ago, so not leaving anytime soon. Okay. Now time to go into print format.c. Okay. Yeah, yeah, that was probably 2 months ago or something at this point. Yeah, the network driver. Yeah, we finished that up and have since moved on to different things. Okay. So now it's complaining about this. Oh, that like it's so where's this thing used? So this thing is used to convert error codes into, I didn't even know you could do this. You can pass %e into print format or something like this. And then you can pass it, I don't know, like one of these error constants, and then that will actually print out an error string. So it's sort of bugging me that I don't really know how, like, what a better solution for this is. Like, it's actually really convenient to be able to just initialize this array like this in C. I'm just like wondering what the easiest way to make this work with C++ is. Here's an idea. I mean, AI has already given us some suggestions last week, like the obvious suggestion that it gives us is to not do it at compile time and move this to runtime somehow, and assign these array entries at runtime somehow. But that requires us to have like a good time to do that. And here's like another idea I will just sketch out quickly, or maybe I'll make it a function. So we're gonna make a function that's going to return this incredibly convoluted type error stir. We'll call it this, and we'll have it take in whatever the type of this thing is. So what's up, Fong? Even though I don't understand anything, I still want to watch. Appreciate that. Yeah, unfortunately, this stuff can get a little bit hairy, especially without the context. But we're just trying to make this work with C++ and figure out all the compilation issues that happen. I think this is an int type. It's just an enum. So I'm just going to error code. So what if we make a function and we internally declare a static array. Wait a sec. So the goal would be just to run this initialization stuff once. And return a pointer to the table. But if I don't, like, the idea is to not, oh wait, I guess, wait, maybe, okay, this is like sort of a bad solution, but we could do a static bool did init equals false. If did init, then we like copy all of these things into here. Something like this. But it's a const. I need to get rid of like one of these consts. There we go. And then just like every single time we return error string, return this array. And then all we did is did init equals true. Yeah, these C array things are so annoying. And a lot of my setup is kind of annoying right now because it's like I'm doing it in such a hacked way. So here's the idea. Rather than having this C array that's like initialized at compile time, basically, which is like kind of cool, I want to just do a very local change. Okay, what is up with it? Okay, here I need to fix my return value. All right, wait a sec. Why is this so complicated? What if I just make it a simple char? So it's an array of char pointers, right? Super simple. This is saying return value type does not match the function type. Interesting. Is max error 16? It is 16. So technically the type of this thing is a char star like 16 array, which I don't really want to like, I don't like, so basically it's saying this thing needs to, I actually don't even know. It's like, it would need to have like a 16 or something here, I'm thinking. But that's not valid syntax. I actually don't know what the valid syntax is. You know, maybe just for learning. Let's check it out. Also, what's up, Krishna? Oh, okay, no, I think, oh yeah, I think you're right. Wait, is it? Yeah, it's a double char pointer. That's true. That's true. And so this is like not super great, but it allows us to just kind of like convert this C array into something we can kind of use from C++. And so now anytime we would have previously used this error string variable, we're now just going to replace it to a function call to this. And actually we need to, wait a sec, what am I doing? So actually no. I mean, we could do it different ways, but as a most direct replacement, this thing doesn't take an argument. It just returns the table. And then the client, instead of directly accessing the global variable, you call the function to get the table and then index into it. The reason, Fu Manchu, the reason we can't statically initialize it is because that does not work with this C++ compiler. This non-trivial designated initializers thing. Oops. Yeah, it's not able to handle this. And so now that we got rid of that, now it compiles through. So yeah, it would be really nice. And just again, just to see what the AI says. This error with these lines when trying to compile the C code base with a C++ compiler. Any advice? Don't generate code. Yeah. Move to runtime initialization. We already kind of did this. Use like normal initialization, which sort of sucks because then you need to manually just make sure this thing is in the right place in the array corresponding to this constant. Use a different data structure or compile SC. So basically none of these options are super good. The best option that I can see is just number 1, which is what we've kind of done. So we're just going to comment that out. And keep going. Oh, dang. Okay, this is an interesting problem when compiling C++ code bases, or C code bases with the C++ compiler. You have to be careful about the word, like the keyword class. And apparently, wait, what? 115. So like there's this variable named class, which is not valid in C++. That's kind of a interesting one. What should I rename this variable to? I'm just gonna do class with all right, just these 3 things. Okay, now this is interesting. Now we're getting into lightweight IP. What to do about this? Yeah, I mean, I don't really want to compile this with the C++ compiler. It's sort of like a dependency, not really something I want to modify too much. So for the moment, I think I'm just going to remove networking support from the kernel. Yeah. I think, yeah, I'm like, the goal is not exactly to get the kernel like completely fully working as it was previously. Whip or more C++ fixes disable error. I'm totally happy to just like remove features if we need for the moment. Yeah. What's up, Ragil? Okay. So removing networking support. So what does that involve? Hopefully that won't be too hard. So we just needed to go to the makefile, and we need to do a few things. Actually, where is so here is the make file for this. I want to go to, but who is including it? Is it here? Yeah, so we're just gonna not, we're just gonna not include any of this. We're just gonna ignore the entire net subtree. Yeah. What happens if we do that? Oh shit. Obj user hello. So Jomo, where can I find lab 6? That's just on the website. I mean, I can try to just pull it up really quick for you if you can't find it. Yeah, I just have this thing saved here. Dang, all right. What if I just make clean and retry? We still get this error. No rule to make target obj user hello. Why not? Needed by obj current kernel. There's these things. So this is what it's talking about. The kernel says it depends on some bin files, which it's trying to basically just bake into the kernel binary. Okay, what is going on? No rule. So that's a bit strange. All I did was this one thing. So theoretically, if I add that back, we'll get the original error. Okay, cool. So I'm going to take this away again. So while it's in net makefrag, was something important in there? It's only these net things, so I don't think that should be that important. But now it's saying no rule to make target, blah, 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 blah. All right, I'm gonna let Copilot cook on that while I also think about this. I'm getting this build error currently. Help code base. All right, so it's gonna cook on that while we also think about that. What's up, Ismail? Nice to see you, man. Okay, it's really oh wait, shit! Did I not paste the error? Okay, whoops. I'm currently getting this compile error with the make files. Help. Yes, sir. Chill kernel hack Sunday like usual. Today's one of those kind of trying to make the build work Sundays. Yeah, we're like looking into the C++ stuff again and just seeing what it's like to compile the kernel with C++. And I didn't really want to get, I mean, there's a couple of solutions to this problem maybe. One might be to actually just revert back to compiling it with a normal C compiler. Just like actually do things the right way. And actually, how does it, yeah, like if something, and actually change the file extensions, which I was being a little bit lazy. And just didn't do that. But that might be the actual, is it already another time for a break? All right, let's take 20 seconds. I'll be right back. So yeah, Fu Manchu, I'm streaming on YouTube right now also. So yeah, we got people on both places. What? This is the weirdest. You know what? This is like kind of crazy. Yeah, I don't know. I'm sort of just. Oh, wow. Continue. I think it's getting somewhere, actually. This is just kind of fascinating to watch. The library? What? No, I think it's All right, I think we're getting a bit out of control here, to be honest. Like, trying to compile the whole thing with C++, it was kind of working, but then it started running into issues with the network stack, which I didn't really want to. I don't want to compile that with C++, and so now I'm trying to just disable networking, and that like broke the build in like an extremely obscure way. Oh man. And now it and then basically Ismail, I just when I disabled the networking part of the build system, the build broke in an extremely obscure way, and I just sent Copilot to go like try to like fix that, and like in parallel to like me trying to think about it. And honestly, I don't really know what it's doing. But it is cooking. It's absolutely cooking. Okay, now, okay, it is really starting to getting lost now. Wow, it's, this is incredible. What is it doing? Oh shit, some name mingling. Yeah, like in some ways, my approach here is not great. Like just to try to compile the entire kernel with C++, it would be much easier to kind of start fresh with C++ and kind of build up from there. Okay, wow. All right, maybe we take a step back. Yeah, maybe we just take a quick step back to Miro quickly. So, what is this? Yeah. Trying to compile entire kernel with C++ compiler, but did it in a kind of lazy way. Didn't even rename files .cpp. Simply replaced the cc variable with a C++ compiler. Things were broken, but we were fixing compile issues. But then whip started to fail to compile. We don't really want to modify whip to make it compile with a C++ compiler. So then the idea was to disable networking fully. That produced exotic build errors. Yeah, and so there's some ways we can proceed from here before we go too deep in the rabbit hole. One, we can continue trying to patch whip and everything else to get it to compile. Two, what else could we do? We could go back and try to do things properly. Actually change the file extension. So C++ uses C++ compiler, uses C compiler. I think a lot of the problems we're having are simply based on the fact that I was like very lazy with that. So that is kind of an option. We could, I don't know, we could even strip down the kernel even more to a bare level, like no user space at all, and just play with some C++ features there. Do we need to strip a lot of C++ features to build a kernel with a C++ compiler? Yes, that is absolutely true. And to show you what that looks like, we can check out the CXX flags. These are something that I found them by Googling it last week. And some of these are a bit exotic, like the first one and this one. Some of them are a little bit more easy to understand. This is like kind of what you're talking about. No RTTI, no exceptions, no standard lib, basically. So that's like kind of it, which is like, yeah, it could be worse. So I feel like just a couple of these flags. Yeah, I also thought there was this free standing thing, but I have not been using that yet. Yeah. So what do we do now? We're kind of deep in this hole. I don't love being like in such a strange state with I don't want to, like, it's like such a weird build error and it's not super fun to debug that kind of thing. So maybe 2 could be worth a try. Maybe let's just explore what that would look like. And maybe we could even use Copilot to help us go super fast with that process. So at a basic level, what we need to do is we need to rename all of these .c files to be named .cpp. Or I guess technically these two. We're going to rename all the kernel source files to end with .cpp, except for the ones we specifically want to be compiled with the C compiler. That will allow us to write some makefile rules that, like, instead of, so that will allow us to have, like, we can have one of these things for C files and then another one for C++ files. I'm just curious, how is user space compiled? compiled actually. So in a similar way, yeah. Or lib make frag. The pattern's kind of the same. We just declare all these C files, and then there are just these rules. And theoretically, we wouldn't need to touch any of the user space directories, because I'm not trying to make those compile with C++ right now. I'm only trying to make the kernel compile with C++. And part of like the problem we're seeing is because I was just very naively like switching out the C compiler with a C++ compiler, which was affecting absolutely everything in the system. So it was trying to compile all of the kernel, all of user space with a C++ compiler. And that sort of, we got like a little bit of progress with that, but it's going to be a waste of time to just get user space to compile with C++, which is not really the goal here. So I'm somewhat confident in at least trying this idea of number 2. Yeah, so I think we can go for that. And let's see if we can use AI to intelligently like help us with this process, for example. So here's like all these changes it made. I'm going to reject all of them. I'm going to also delete this. Yeah, what's up, John? Yeah, basically yes. It's going to be a couple steps. Like we just need to rename all the files .cpp and add another rule, and then we need to like clean up this C flags situation a little bit too, because right now it's kind of messy because the C flags get inserted into the C++ flags get inserted into the C flags. Yeah, I was trying to make it all C++ all at once, but yeah, that's a bad idea. It's just way too much, and making user space compile with C++ is not something I want to do. Yeah. Yeah, the idea was to go incrementally. And my idea to do that was to first just compile everything with the C++ compiler, like not necessarily use new language features, but just compile everything with a C++ compiler, and then start to use new features in the areas I want to. But yeah, that's pretty hard. And so, yeah, just going a bit more granular, like you're saying, is probably the move here. So, all right, I'm just gonna clean this up. So let's just start out with this. Right. Can you rename all these files to end with .cpp except for entry page .c and any .s files? Did it cancel my selection? All right, this is going super, this is like super slow. Maybe I can just do this faster myself. So, ag v entry page dir, right? So now we have all of these things, and headers stay in .h, right? Probably, yeah. I mean, ideally, I think they would also be HPP, but for the purposes of just getting things compiling, I think, yeah, they can just stay .h. Okay, and because I don't really know how to use XRs, I always forget, I just do loops. And so for, these are all our C files, and I'm just gonna do, oh shit. Echo is base name. Echo base name X. Actually, no, wait a sec. I can just do this. Move X, X, PP. Wait. Okay, no, it's gonna be something like X, PP. I'm just gonna echo it first. Yeah. Okay. Okay. So now we have like a ton of C++ file extensions here. Wait, maybe I'm going way too fast. John was saying, dude, like don't compile everything in C++ at once. Just add a new build rule and then just do it one file at a time, which is actually what he meant, and that's actually a way better idea. Yeah. So let's do that. Yeah. So right, it makes sense. Okay, so let's add that rule John was talking about. So basically, it's going to look something like this. And if we happen to have a C++ file, we can, I'm just sketching out in theory what this would look like. We just run the C++ compiler on it, and for the moment, do vars current C x flags thing. Right. So in theory, this is what we need to do. No, std inc probably too, yeah. Okay. So super minimal build rule. And now we need to actually get this flags situation sorted. But before that, first, okay, so first, we'll do this change, and then we'll do cxx, well, veal, and then g++. Oh wait, okay, so yeah, this CC thing needs to go. So basically, we just have the GCC and the G++ here. And now we go back here and we can kind of comment this whole thing out. What? Okay. Yeah, we have our .c rule and our C++ rule. Okay. So now it's time to go here. So now we're gonna have okay, so we're going to kind of revert this. See this thing, okay. What are defs? I guess defs are things that can come externally, like from an environment variable. Okay. So now, so a lot of these things are common to both of them. I think I can't, like, it's gonna be something like, so there's like the C++ only ones, and there's the C only ones. Static. F, no, omit frame pointer. I don't know if exactly all of these will, okay, so these are only necessary for user space, but that sort of doesn't matter for the moment. And this no stack protector thing, whatever. So what about this? Yeah, C exercise flags being a superset of C flags, right? So that's sort of right. So that's sort of what we got here. And so C exercise flags has a bunch of like random stuff just for it, and then we just append all of C flags. And we need to add, but the one thing though is this kind of stupid GNU 99 thing, which doesn't work in C++ mode. So how wrap this? I'm gonna do C only. I'm just gonna do C only flags. And then if I just call this common, this was C flags though. And then this is also common. And then C flags equals common, and then C only flags. appended to C flags after. Oh shit, that's true. Yeah, I mean, we're all like, maybe I'm all, maybe I accidentally just like sort of like did a lot of the work anyway. So now I have this like common thing and XX flags, something like this. So what do we have here? C flags now has a bunch of all this stuff. And then we create our final C flags and CXX flags based off of that with the specific ones. Okay. Cool, so, I mean, actually at this point, we don't have any C++ files in the code base. So this rule shouldn't really even do anything for the moment. What happens? So now I have all of these C++ changes I've added. So what I might do is actually just check out somewhere else. Let's check out here. Damn. All right, didn't really want to get into this situation. Status. All right, you know what? Let's just scrap this actually. Let's just check out back to a sane place and then do what John said. So what does this it have? It has a bunch of stuff. All right, let's take 20. Be right back. Okay, so this already has a bunch of changes that we don't want. Let's even go back before that. Do CPP, call it CPP2. Okay, that looks better. So we're back at a clean compiling state, and let's sort of just loosely recreate that work. So let me go find some of this stuff. So first off, so we need these. So like the main relevant changes. So CXX flags, and then CXX flags plus equals C C flags. But then this thing couldn't really be here, so we'll just add it after. Okay. And then here we want to have CC and then CXX. Blah, blah, blah. Okay. Yeah, right. Okay. So anyway, yeah, thanks again, John. This strategy is way better. So then we get to go here. I forget how make behaves when you append to something after using it elsewhere. We will see. Okay, so what have we done? All we did is some slight tweaks, but everything should still compile. So let's just clarify that. Word, okay. Because we haven't really done anything like too crazy. So now we're in a position to add back that rule. And that rule is over here. So I'm gonna get this back. Okay, so we're missing kern CXX flags. Shit. And that's kind of it. For some reason, the dash G is like weirdly over here, but whatever. And so now we have our rule. And we're ready to add our first C++ source file and just try to link it in with everything else. So let's just do that. Where is my file explorer? Here we go. Okay. So I'm just gonna add a new file, call it test.c++. And what could we do? A super basic thing would be maybe just to, I don't know, like we could add a function and call that from the main kernel. But what would it actually do? It's kind of the question. I mean, we could just make a loop. Like, we could just like halt the system, which is not really a problem. So I'll call it test.hpp. Bogus system call. Yeah, could do that. Maybe I was just trying to like do the smallest possible thing as a proof of concept. And so I called this HPP, but actually, yeah, I don't know. That we're linking it into a C code base, so technically maybe it would actually be more correct for the moment to call it .h, and then extern C, which, so I'm like not super knowledgeable about this part, but if I understand correctly, this is the kind of thing you need to do if you have C++ functions or types that will be used in a larger C code base. This wrapper suppresses name mangling for the symbols. And so now that we just have this stupid thing, yeah. So now that we have this stupid thing, we can go back to make frag and add it here, test.cpp, and I just noticed one thing that's kind of maybe problematic is that these lib files are included. But wait a sec, but they end in .c, so it shouldn't matter at all, actually. So now we've done this ultra basic test using the maximally incremental approach. And we should be able to trigger this make rule if I tab, like indent it correctly. And now what I should be able to do is something like test.o. So if I do make obj current test.o, we can see that it's using the cxx rule and then running our command line with all the C++ stuff. But check it out, it looks like GNU99 got added. And so this is kind of what John was saying earlier. He didn't quite know the behavior if you mutate a flag and use it later. So it seems like the mutation, like when it makes a copy, or it seems like it doesn't use a copy. It somehow, so at this point, I was sort of expecting that it would like make a copy of all the C flags into CXX flags, and then it could independently mutate C flags later, or we could, but then that wouldn't affect CXX flags, and that's not what happened in practice. And so I think I'm just going to ask AI how to handle this. On line 111, I want to add this flag, but only for the C flags. I don't want it to affect CXX flags, even though CXX flags was previously set to have C flags appended at the end. Any advice? Yeah, digitalized. How I've been liking it. You found it unhelpful for concurrent programs. Yeah, I mean, I think I'm getting some value out of it for sure. I mean, we can even see right now, there's like a lot of stuff I just don't know how to do right now, and I think that is actually valuable. Maybe I could have found the information out via the internet, but certainly that would be slower. So I would say overall, yeah, it's definitely helping. Okay, so its solution is simply just to filter out this string, which is kind of hacky. Wait, what? No, it's like it. I think it. Actually, so I'm just gonna give it this command line. Here's a compile command from my build system. It actually seemed like GNU99 was still there, even though the appending to C flags came after setting CXX flags. Wait, what? What? All it did was add comments? Well, this is a start. I'm just gonna go ahead and stage some of this because we got a good start going. And I mean, maybe that filter thing is actually, but wait, but did it? Okay. I want it to please add a line that filters out the text 99 from CX flags. That's just the fastest way to get like something going here, and we can improve that later. So maybe I misunderstood, but now I'm sort of thinking that this would filter this out of filter this string out of this thing, but maybe I am not understanding the order things have. Oh shit. But actually no, it did work. It like totally worked, and we were able to compile this thing now. And so it did seem to successfully strip that string to do properly set the NC flags to avoid this. Okay, so that worked. And so now I accidentally tried to compile like actually the kernel, and something kind of funny happened. It tried to include our C++ file into the link step. And probably, and the reason is because there is like this weird stuff that happens where it takes the file names and then sort of like mutates this list and substitutes file extensions. So now if I compile, now it file not recognized, file format not recognized, entry pager.c. What happened there? Did I like do? Okay, no, yeah. Copied and pasted quickly. So I just like, yeah. Okay, let's try it one time. So that like worked. Just out of curiosity, let's see if we can observe a problem if we forget the extern-c. Like what happens if we just don't have this? My expectation is that we're going to have a linking error, I think, when it tries to link the kernel. Well, actually, wait a sec. No, so I wasn't quite ready yet because I didn't actually call the function. I need to, let's go to init. And let's just call this right after the first text gets printed. We're going to call this loop function, and to have access to it, we need to include kern test. And right, so this is all we got. We have a C++ file and this .h. My expectation is the build's going to fail. And I think that is exactly what we're seeing. Undefined reference to loop in the linker. Yeah, in the linker stage. So that's exactly it. It's not able to link the kernel because it can't actually find the loop symbol. And the reason it can't find the loop symbol is because, wow, why can't I? Is because the symbol got mangled with this like _z or whatever, which is how C++ mangles symbols. And so the C compiler, it's looking for like a normal, I think just even like the text loop or something like that. And so if we add back the extern C and then we recompile, okay, this is interesting. Let's see what happened. So we were trying to compile init.c, and the C compiler. Oh, do we need I think we might need an if-def C++ or something like that also. So the problem is that in our header file .h, we are using C++ syntax. I'm pretty sure that's what, like, this thing doesn't exist in C, I believe. But because it's in a header file, it's being included in this big translation unit that is seen by the C compiler, and it doesn't understand this. So I think I'm going to ask. I think we need like an if-def to selectively include this extern C only if we are compiling a C++ translation unit, if I understand correctly. Let's see what the AI says. Can you solve this issue? What is your recommended solution? Don't generate code yet. I just want to see what it says. My guess would be we need to add some if-defs, and I just want to see what it says. What? Nope, this is not what we want to do. Yeah, exactly. So I think my guess was correct. How do I use this? Apply in editor. Insert at cursor. Yeah, so basically we need some if-defs. Yes. All right, be back in 20. All right, so check it out. So now now the C compiler, when it compiles this file, it's going to slurp in this test and directly inject it right here, but it's not going to see this line or this line because the if-def will filter it out. But when we go to compile test.c++, it, well, we're not even including this file anyway because we don't need to. But let's say we had, I don't know, some other stuff in here that was referenced by this, then this thing would appear. And let's just run it and see what happens. So it actually still didn't work. And I'm wondering actually if that's because I didn't include the header. Include test.h. So that worked. Okay, so actually it is important to include that header, because otherwise the C++ compiler, when it compiles this CPP file, it doesn't know to suppress the name mangling. It just doesn't have this stuff at all. So yeah, so check it out. So now we actually compiled, and what I'm just gonna do is I'm just gonna comment this out. We're just like, if that actually did run, it's going to cause an infinite loop. But what I just want to do is run the kernel normally, just for baseline sanity. Okay, I kind of messed up there actually, because it actually did. I forgot to rebuild, or did I? Okay, here we go. So this is the normal kernel without our new C++ thing. And then I go here and I re-enable this and I rebuild and then I run QEMU, and we see something different. It is printing less text because the kernel is caught in this infinite loop, which is coming from the C++ world, which is coming from our C++ file. And so that is, that means it's working. So I'm just gonna get some claps in here. What's up, Natronics? Someone guide me as to how someone who just knows the bare bottom functions, if else loops, and C to get into OS dev, compiler dev, all these cool things. Yeah, totally. My recommendation is I don't know, like I didn't do it, but Harvard CS61 is I think a good fit for your level. And I have this random list of links on my website which are not that good, but like maybe that'll give you some direction also. So so that's actually working. And so yeah, I have to give a big shout out to John if you're still here. This approach is definitely way better than the one I was originally thinking of, and it's way easier and way more incremental. So now we can let's wait for Mark to publish a book. Maybe someday, if there's enough interest, I could consider it. Yeah, so now what this allows us to do is we can, like, if we want to add new functionality to the kernel, we can do that in C++ files, but then have the normal C kernel call into them. And then also, if we wanted to, we could start to take these existing .c files and convert them to .cpp files. So that's cool. And it didn't take that much work necessarily. So let's just review the diff. So what did we do? We added a new variable in the make file that has the C++ compiler. We added a variable that has some flags that are only for C++. we set the CXX flags variable to have all that C++ special stuff plus all of the normal C stuff, except this one particular thing with the GNU 99. And so we, that thing only belongs in the C flags. And so we like add it there, but then we like need to filter it out actually. So actually, I suppose we could leave this here and then just leave this filter thing out. This is not like a great way to do this. A better version would be to properly have variables for the C++ only, C only stuff, C++ only, C only, and then the common ones, and then construct the final CXX flags and C flags from the C++ only plus the common, and then the C only plus the common. But for the moment, this like kind of hackily works. And then we just have our new C++ file and a small amount of patching the build system just to make that all work. And then in our build rule, this is how we convert from C++ to .o, and we just call CXX and then pass the CXX flags. And then here we have our just proof of concept. So that's like cool, and I don't know, let's just try to use some C++ features. So let's have a struct, my struct, and it's going to have an int x and then a method. I mean, the sort of unfortunate thing is like, how can we call C functions from the C++ file? And let's just try that actually. So how does that even work? So we need to get the console header, I think. Got the console, and that gives us access to cprintf, maybe. So we'll just say entering inf loop. And then this thing has a squiggly line because this is undefined. Okay, because that's not in this header. What is the header? Is it like stdio.h? Just gonna quickly cprintf, but all right, I think it is stdio.h. So let's just try using that instead. And check it out. Okay, so that was the right header. The squiggly disappears. And let's just see if that can work. So now we have a problem, undefined reference. Undefined reference. Okay. So it's not. So yeah. So one part of like getting this working is on one end we should be able to call C++ from the C world, which we have shown that we can kind of do. It would also be really nice to be able to call C from the C++ world. And what am I doing wrong about that? It's probably the name mangling thing again. So my guess is that when all this runs through the C++ compile, it's going to see this header, and it's going to interpret it all as C++. And so I think we need to suppress this in the same way. So I'm just going to include this kind of as high as possible, and here put this as low as possible, approximately here. Yep, linker error for sure. And so what's the rule? So it seems like we need these wrappers if we have a header that declares functions that are implemented in a C++ file. We need these. And if we have a header that declares functions that are used by a C++ file. I guess one other solution is we could actually just do this, now that I think about it. And that actually is a bit nicer. We don't need to mutate this stuff. So now purely in the C, just in the C++ file for any of these headers, which we know are C headers, we just include them wrapped in this thing. And that seems like it has fixed everything. So now this would be kind of cool. Entering inf loop. So that's pretty sweet. So yeah, we're doing it. We are able to call into the C world and call functions in both ways. So now we're sort of ready to incrementally introduce C++ into the kernel if we felt like it. So I'm gonna get some more claps out for that. Yeah, thanks Ismail. I mean, I really have to thank John again for kind of redirecting there. I think I would have gone in sort of a weird direction had he not offered that good idea to sort of like really go even more incremental with everything. But yeah, like, so now to finally celebrate, let's do some C++. Let's I mean, it's like, let's just say void hello or something, some dumb thing like this. Hello from my struct. And actually, you know what? Let's just make this a template. Type name T. And we have a T, X. And actually, I don't know what we would even do with that, really. All right, never mind. I'll just make it an int again for the moment. And we can print out the value of X. And so we can do some stuff like my struct s to x equals 42, s.hello. You know, this is some real C++ type of features going on right here. No instance of constructor matches the argument. Interesting. What? There's no argument list, so I'm a little bit confused by that. Template deduction failed. Okay, so we gotta not have that. So hello from my struct 42. So now we can have, and then we can, I don't know, we can set this to 100 and then have it say hello again, you know. 42, 100. So yeah, so we're using some C++ features and that's compiling and it's working. Anything else we could do? I mean, well, is anything that we sort of simple support over? To C++. These are all kind of larger. What would be like something really small? You know, it would be kind of cool to like port a lock or something over to C++. That might be a relatively easy thing to do. Multi-boot tag parsing. I mean, now like we don't really need to. Can you do RAII in the kernel? Is it useful? Yes, absolutely. Absolutely. That's like a very key thing to C++. And so we can have a nice destructor. Destroying object. And maybe I can also add a constructor here too. CTOR objects. And RAII is just sort of observing that, you know, we're just going to see the constructor and destructor fire. And I'm just going to get rid of the while because we don't really even need that anymore. Things are working. Also, shout out to Leemine. We got our Leemine bootloader booting us. And here we can see it, CTOR object, hello 42, hello 100, destroying object. And that means that destructors are working. And that's the core foundation for RAII, where now we can build smart pointers. Now we can build kind of like scoped resource manager data types and lean on the C++ lifetime system to make sure like memory is freed and stuff like this. So absolutely. So I think in general, we'll kind of bring the stream to an end, but I did want to quickly kind of go through the OSDev wiki, because there was a lot of other stuff here that we haven't touched yet. I mean, actually, you know what would be really cool just to test out is virtual functions. Does that work? Yeah, thanks, Ismail. It's small steps, but it's just all about locking in these little wins every time. So yeah, I mean, there's a bunch of stuff here. Global objects are one thing. I think. So basically, I think there's a lot of stuff we can't use yet because we just haven't. I don't know, just like added the correct setup. So for example, global objects would be one thing. I think you need to write a bunch of code to like call constructors or something like this. I don't really know much about that. So if we wanted to use global objects, then we would need to do something. Local static variables. Okay, I don't really know. New and delete. Yeah, I'm not really that interested in new and delete. I'm not sure we even really need them. We can just use explicit memory allocation. Yeah, these are just, okay, RTTI might be kind of interesting. Virtual functions work without RTTI. So let's just to kind of wind it down, let's just do a virtual functions demo. And so I'm gonna have a struct I interface, and we'll do that after. Wait, actually no, I'm just gonna kill the palm tree. We're kind of coming down to the end of time anyway. So we're gonna have an interface, and what do we need? We need a virtual destructor, and I don't remember the exact syntax for that. But then we could say something like, hello, this is like the worst, this is like the most classic example of this. And we could have like a struct dog or whatever. And it inherits from I interface, which just means it needs to implement this. I am a dog. This is, yeah, again, this is like not anything really that groundbreaking, but this is just kind of demoing some C++ stuff. Cat. And we have this interface, and now we can have a function that takes a reference to, I'm gonna call it an animal. And actually, I'm just gonna rename this to iAnimal because I ended up doing kind of animal thing, the const reference, and we'll call animal.hello. And with the member function. So we need to make this const, I believe. Okay, so now we can do this. And then now we can just do some stuff like we get a dog over here, we get a cat over here, and we're gonna call type abstract class. That's has no override. Okay, so we need to override. Const, it's the const thing. That would do it, I believe. Oh yeah. Okay, so we have our interface, got a cat, dog. Yeah, this is the classic thing. And we're just gonna say, we're just gonna call func d, func c. And then we're basically able to write code that operates like on different implementations of an interface, which is one of the, which can be very useful. Yeah. Hello, struct, blah, blah, blah. I'm a dog, I'm a cat. So check that out. That's like pretty cool. We don't even need a lot of, we don't need exceptions. We don't need RTTI, but we can still have some nice things like virtual functions, which is not inheritance, by the way. Like this, I mean, it uses the inheritance syntax, but we're just inheriting from a pure virtual interface. So for all the people that are like, inheritance sucks, this is not really what we're doing here. We're just using it more like interfaces here. And we're able to use some of these features, which can be helpful sometimes. And now we get references. That's huge. I'm a huge fan of references, to be honest. I'm extremely excited to be able to use references with the main reason, like they're better than pointers for a lot of cases because they cannot be null. And so you can just like use them and be confident that you won't segfault. Be a bit more confident that you won't segfault. So anyway, so that's cool. I'm glad we were able to get somewhere with this stream. And I haven't even checked my stats the whole time. We got 20 20 viewers or 16 viewers in the chat. Super cool. Yeah. All right, y'all. I think that's going to be it for today. That was cool. Got some C++ going. Got our incremental ability to use C++ going. Let me, as usual, just self-promote myself. Feel free to join the Discord if you want to keep chatting about this. Subscribe to my channel if you are interested in this stuff. And I wish you a great week. Have a nice week, and I'll see you next one. Peace.